Okay, ladies, we're still looking at absolute values, and we're going to look at questions like question 9. And it says use cases to help sketch the branches of y equals absolute value of x. Now, I haven't explained to you what that is, all right, but it's got to do with the definition. And it says in each part, identify these shifts, and they want us to write down the equations of the two branches. So we're going to go to Desmos, and I'm going to show you what this means, and then we're going to do it on pen and paper. Okay, so I'm going to draw y equals absolute value of x in Desmos, and you're going to see that there's actually two equations there. And then we might sketch y equals absolute value of x minus 3 in Desmos as well. Okay, so I'm sketching y equals absolute value of x, and from last lesson, you know what that looks like. It's the V shape, okay? Girls, the equation of this line here is different to the equation of this line. Just by looking at this line here, that bit there, the bit on the right. If x is positive, when x is positive, what's the absolute value of x, girls? X. So see how that part of the line, now watch what I'm doing. I'm taking off the blue. That part of the line is the equation y equals x. Are we okay with that? Because when x is positive, look at the values of x here. X is 1, 2, 3. These are all positive x values. So absolute value of 1 is 1. Absolute value of 2 is 2. So this side of the graph is y equals positive x. Do you think that line, see the blue line, 1, has that got a positive gradient or a negative gradient? Positive. So that branch of the line is y equals x. What do you think the other branch of the line might be? Very good. And it is, because look, all right, I'll get rid of the blue one and the green. Look, the green is y equals negative x. Why? Because the definition, we looked at the definition last lesson that the absolute value of x is negative x, and I'm going to show it to you, when the values of x are negative. Because look, when x is negative 1, what's the absolute value of negative 1? What's the absolute value of negative 1? 1. Because you do negative, negative 1. Okay? That's why this is the equation. So when you have an absolute value equation, you have to write the positive version of the equation and the negative version of the equation. And they're your two equations. They're your two cases. So my first case is y equals x when x is positive. My second case is y equals x only when x is negative. See how the green line comes down here? That doesn't form part of my graph because I only use the equation y equals negative x when x is negative. And I only use the equation y equals positive x when x has positive values over here, not for these values. See how it bounces back up? Look at the red line there. If I graph y equals x, that red part is only y equals x when x is positive for these values of x. Do you get it? It's not down here. It's not the line y equals x for negative values of x. All right, the green line, so that red bit there is the green line, but only for the negative values of x here. All right. With cases. Now, when I draw the graph of y equals the absolute value of x, it looks like, I'm going to draw it, it looks like this. The graph looks like that and this. I'm doing it in different colors. Sorry, that's meant to be the same gradient, sorry. That's just a straight line, and so is the other one. So this is y equals absolute value of x. We learned that yesterday. That's the graph. I've done one bit there, make yours a bit nicer than mine, and the red bit. The reason I've done them in two colors is that they have two different equations. So this is y equals absolute value of x. So when I write it in cases, I say to myself, well, y can be x, y equals x for x greater than 0. So if x is positive, the absolute value of x is just x, so that's my first equation. So this here is the line y equals x, but only for positive values of x. And the red line is, you know how we say, all right, this can be x, or absolute value of x can be negative x for x less than 0. So the equation of the red part of the absolute value graph its equation is y is negative x. See, that's got a negative gradient, that's got a positive gradient. This is part of the line y equals x. This is part of the line y equals negative x. What I mean by part of the line, it's only that equation when x has negative values over here, you know, -1, -2, -3, etc. Can you see it? It's only for the negative values. And that's what the cases are. So we're going to do it for another graph now. So I'm just labeling each part of the graph. So that's the line y equals x, that's the line y equals negative x. All right, we're going to sketch y equals absolute value of x minus 3 and write the equation of each graph as well using cases. Each part of the graph, using cases. So that's y equals absolute value of x. So we're going to do the same thing. Now yesterday, you just learned how to sketch it. Today we're going to write the equation of each branch and then we're going to solve some problems as well. Okay? Have you finished with the first graph? Can I move it down? All right, here we go. All right, let's sketch it first. What does it look like? So this is the graph, y equals absolute value of x shifted where? 3 left, 3 right, 3 where? 3 right. So this would be 3. It's going to go like this, and it's going to go like that. Can anyone tell me what, sorry, they're meant to be, what this point is? It's really good idea, girls, to have, well, you always should, not a good idea, you should always put the x and the y-intercepts on your graph. So when x is 0, what's y here? When x is 0, what is it? Yes? When x is 0, 0 minus 3 is negative 3. Absolute value of negative 3 is 3. Now, I need to know the equation of each line. So you know how I've got y equals absolute value of x minus 3? I've got that if this is positive, if the x minus 3 is positive, my equation is just that, isn't it? If x minus 3 is positive. Now, girls, can we solve that equation? So the equation will just be, as you see it, y equals x minus 3 if x minus 3 is positive. Can you solve x minus 3 is greater than 0 for me? X is greater than what? Take the, how do you solve, yeah, x is greater than 3. You know, taking the minus 3, inverse operation of minus 3 is plus 3. So in other words, the equation, this equation is y equals x minus 3 of that line. Got it? Now what about the red line? The red line, so if this is negative, by the definition of absolute value, to make it positive, y will be the negative of what's in there if x minus 3 is negative. So let's say x minus 3 was negative 4. Let's say it was negative 4, the answer to that. You do the absolute value of negative 4 is negative negative 4, which is positive 4. So you write it with the positive case. So this is my first case, the positive case. Y equals x minus 3 if x minus 3 is greater than 0, or I could just say that means if x is greater than 3. And the other equation is that y equals negative x minus 3 if the x minus 3 is negative. So if that's negative, you get negative negative and you get the positive answer for the absolute value. Now I'm going to rearrange this. That's negative x plus 3. That's the equation of the other line. Can we solve this? X minus 3 is less than 0 is the same as x is less than what? 3. Now let's just have a look if that makes sense. So it's telling me that the equation of my line is y equals x minus 3 if x is greater than 3. Yep, see? X is 4, x is 5, yep, that works. And the equation of my line is y equals negative x. Hasn't that got a negative gradient? And what's the y-intercept? Plus 3? Makes sense. If the values of x are less than 3, and they are in the red section, the values of x are all less than 3. Okay, so my two equations are, they're my two cases. So I've got that the equation of this line is y equals x minus 3, and I can see that only applies for values of x greater than 3. And my second equation over here is y equals negative x plus 3. And it makes sense. It's got a gradient of -1 and a y-intercept of positive 3. And that is the equation only if my values of x are less than 3. Is y equals absolute value, of x minus 3. The blue graph is just the x minus 3 positive gradient. Okay, but it's only for values of x greater than 3. And the green graph is y equals negative x plus 3. It sits on top of the other one. Okay, so they're the equations of the two lines using cases. Okay, girls, so we've just done that question. We've written the equation of the two branches for y equals x minus 3. Let's try this one. It's a little bit different. So we're going to do 5, y equals absolute value of x minus 2 minus 1. We're going to sketch that, or actually we may not sketch it. We're just going to do that question and write down the two, and no, it does say to sketch. So we're going to sketch it and write down the equations of the two branches. Okay? So girls, our cases would be that x minus, I might actually put the case in the heading. Couldn't this be positive? Don't you have to do a positive version of this and a negative version of the absolute value? So cases. The first case will be if x minus 2, so case 1, I'm going to go, if x minus 2 is positive. Does that make sense? Or x is greater than 2. What does my equation become? Don't I just write it normally? If that bit in the absolute value sign is positive, you just write it as it is. Now, I don't need brackets around it. So I've just got x minus 2 minus 1. What's the equation of this line? If the x minus 2 bit is positive. X minus what? So that's positive. So there'll be one case where this is positive. So if this is positive, its absolute value is the same answer. So case 1, that's positive, or if I rearrange that, if x is greater than 2, you get x minus 2 minus 1, which is x minus 3. That's my first case. My second case is if the x minus 2 is negative. In other words, if x is less than what? No. X minus 2 is less than 0. If what's in there is either going to be positive or what's in the absolute value sign is negative. X is, just rearrange it. X is less than 2. I could put it underneath. I'm just solving it for x. So how do I write this out? Do I write out the x minus 2 normally, or what do I put in front of it now? Negative bracket x minus 2. Just keep the 1. It's got nothing. There's no absolute value sign around the 1. It's always take away 1. All right? Now, how do I expand this? Go. Negative x plus 2 minus 1. So it's y equals negative x what? Plus 1. They're my two equations. So if I sketch this, those will be the two equations of my line. So all you do, keep the absolute value bit once you do it positive, and then you do it negative. Now this minus 1's got nothing to do with it, the take away 1. So if I did sketch it, you tell me how to sketch it anyway. So y equals absolute value of x minus 2 minus 1 is the graph. Y equals absolute value of x shifted where? 2 left or right? 2 where? 2 right and 1 up or down? Down. No, it's only when it's inside a bracket that the shift is opposite to what you see. The whole graph gets shifted down 1. So if I was to sketch that, look, I'm going to use a pencil and sketch where the others are first. So if I was sketching this, I would say, this is y equals absolute value of x, right? Shifted 2 right is like this, maybe like this. Shifting 2 right, and then I shift 1 down. Okay? So there's my original. I'm going to shift it 2 right, and then I'm going to shift it 1 down. Whoops. Like that. So it's going to look like that. I better draw it a bit better. It starts like that. That's absolute value of x. Then it's going to be shifted 2 to the right, where that's 2 and that's 2. And then we're going to shift it 1 down. So it's going to look like this. So what would this point be if you've shifted 2 right, 1 down? What is this vertex, girls? 2, -1. Beautiful. Be careful with this. If you want to know now, girls, I've got 2 equations. Just by looking at the equations, this has got the positive gradient and that one's got the negative gradient. So which equation is this one? The first one or the second one? This has got the positive gradient, so there should be a positive value in front of the x. This is y equals x minus 3. Now, if I continued that line, it would cut through at -3. And the other line, this is the negative gradient one. This is y equals -x plus 1. What do you think this value is here? This one, the y-intercept. All right, do we get that this is that? So if this has got the negative gradient, it has to be this equation. So when x is 0, -0 is just 0 plus 1 is 1. Okay? So you've got to be careful when you're looking for the y-intercept. You've got to know which graph you're substituting into. That is the negative gradient. Do you see how they go together? These two. Negative gradient, -x, that's the line that slopes that way. And this is the line that slopes, that is increasing or slope, that's got a positive gradient. Now, you can't see the y-intercept for this line because it's all the way down there, but it would be -3 if it continued. Remember, absolute value is still a V shape, but it's been shifted 2 across and 1 down, and they're the equations of both branches of the line. Okay? Graph, y equals absolute value of x minus 2, so it started here, it shifted across 2 and down 1. This is the equation of the positive branch, like the positive gradient. Okay, it would be x minus 2 minus 1, which is x minus 3. You can see that that sits on top of the red line, but only for values of x greater than 2. Right? And this other branch here is -x. It's got a negative gradient. It's got a y-intercept of 1, but it is only for values of x less than 2. Okay? So the 2 equations are for different domains, for different values of x. Okay? Question 10, we won't do it now. You'll do this for homework. So you would write y equals 2x for 2x greater than 0 or x greater than 0, and y equals -2x if -2x was less than 0. So this is just the absolute value of x function steeper. You know, the 2 is in front of the x. Still got origin, it still passes through 0, 0. What about this one? Will this be steeper or flatter? So this is a V shape, still flatter. All right? Now what we're going to